Greetings, everyone. Welcome to another episode of 3D Universe Untethered. I'm Jeremy Simon, and it's a pleasure to be with you again. In this episode, I get to sit down with Jason Enders from RE Suspension. And I'm going to be telling you a lot more about him in just a moment as I bring him on screen. But just to lead us into this, I wanted to say, if those of you who've seen these before, you know that I love to focus on the stories with our customers and others in the industry where they're being able to do things with this digital fabrication technology, build a business, pursue a passion, and create a new, kind of path forward for themselves using with the help of this technology. And those stories are always wonderful and exciting. I will point out that this one is a little bit different because, Jason has built a very successful business company, 17 years. And to be honest, they would probably be doing just great with or without the 3D printing and the laser cutting and all that stuff they're doing. But no doubt it helps them. And so that's kind of the angle that we're going to be focusing on in this one, is sort of how they're bringing this more and more into their business, and how they're seeing advantages from incorporating digital fabrication into an already successful business. And so let me bring Jason on screen here and get started. Welcome, Jason. Glad you could join me.
Oh, thanks for having me, Jeremy.
Of course. So RE Suspension. So let's talk a little bit about this. And I just want to give our watchers and listeners a little bit of a background here. You guys are a full-service suspension company, and I loved what you said in one of your videos I saw on your YouTube channel. You said, if it has wheels and you race it, we develop suspension packages for it.
Yep.
Right there. So I'm going to go ahead and just kind of read the folks a little overview of your background here, and then we'll get into a bit of a discussion. So in 2002, Jason Enders was working as a full-time mechanic for a NASCAR Cup team when he began noticing a true need for a company that could offer advanced suspension technology to racers across the country, regardless of the series of competition. Since its launch, RE Suspension has become an industry leader. Headquartered in a 10,000 square foot building located in the heart of motorsports country, Mooresville, North Carolina, RE Suspension sets the standard with their advanced testing equipment, including two EMA dynos, an advanced spring rater, a 10 horsepower dyno, and a 5 horsepower dyno. RE Suspension has innovative products, full inventory from top vendors, and knowledgeable, talented technicians. As RE Suspension continues to grow, they look to the future of motorsports as their in-house engineering department uses the latest in 3D printing and sophisticated 3D modeling software to design and create their own line of suspension parts and tools. So that's pretty cool stuff. But like I said, Jason, I want to talk a little bit about the history here before we get into the digital fabrication stuff, which is, of course, where I want to get to. But I'd like our listeners to be able to get a better understanding, as I've had the opportunity to, of your background. Let's start with how you got into racing, and then we'll get into the whole story of RE Suspension. So how did you get into racing yourself?
Well, unlike a lot of people, had the lucky fortune of being born into the sport. So growing up, I was born in Ohio, and my dad was in road racing. And he crew chiefed and worked on several different race teams up there. And in 1987, the team that Dad was crew chiefing for, they decided to go cup racing. So Winston Cup, that is NASCAR. So they started a NASCAR team in Ohio and ran it for about half a year. And at the end of that season, Dad sat down with the owner and was like, if we're going to do NASCAR, we have to be in Mooresville. We got to move down to North Carolina. So Dad closed up his business. He had a auto parts store and a auto service store, and closed it up and moved the family to North Carolina. And there began my racing career. Growing up, in high school, I'd go to school, and soon as school was out, I'd jump in the truck and drive down to the shop and help Dad. And that continued through college. I'd go to classes in the morning and help my dad in the afternoon. And after college, my dad said, if you're going to do this for a living, you've got to go work for somebody else. You can't work for your dad your whole life. So I did. And I went to, I worked for 3 or 4 different teams, and somewhere in the middle there, it was 1999, I think. In 99, I decided that I didn't want to be on the road anymore, because working for NASCAR and being on the road, and I was newly married, and you know, we were starting to build a family, and it's like, this isn't what I want to do. And I was in a point where I, in my soul, I hated racing. Like, I've got to get out of this sport. And I did a little soul searching, and it's like, wait a minute, Jason, you don't hate racing. You just hate where you're at. I was in the middle of it, and I was tired of being gone and living out of my suitcase. So I quit and went to work for BSR Products, who they were like a parts store that serviced all of NASCAR, and they had a shock division. And my dad was in between jobs. The team he was crew chiefing for closed up, and he was in between. So they hired my dad to come and run this little shock division. So at the time, I didn't have anything to do either. So I'd go and help dad. And that turned into they hired me, and I worked there for a couple of years. Well, again, this company that I was at, their sole focus was NASCAR. And while I was working there, I started going to some short track races, local Saturday night racing, and realized that there's a whole nother market out here that is totally unserviced. These guys need help, and there's nobody to help them. And I tried to get them to pay attention to it, and they didn't. So I ended up quitting and got hooked up with Kurt Rohrig, who, without Kurt, I wouldn't be where I am today. But Kurt, he built the machines, the dynos that we test all the shock absorbers with. So I drove up to Kurt's shop and told him my plan. It's like, I want to do this shock service company. I want to house all the major brands, and I want to service everything from NASCAR and IndyCar all the way down to your Saturday night dirt track racers. And he agreed. He took a chance on I think I was 28. I was 28 years old at the time, and we did it. So Kurt helped me get started. He gave me a dyno, one of the testing pieces that I needed. And from the very beginning, this place took off. We've grown. You know, when I first started, we were in a 1,250 square foot little Keyman space, and now we've grown into, like I said, we've got 10,000 square feet and 8 employees, and growing. It's as we were talking earlier, we're trying to hire more people as we speak. So it's just taken off from there, and it gives us the position that we're in gives me a really good opportunity to be in racing and not be in racing. And it also gives us the opportunity to have our fingers into all forms of motorsports. Again, from the NASCAR bunch and Indy cars and road racing, all the way down to your local Saturday night grassroots racer. And it's been a fun ride.
I bet. So then let's get into the business a little bit more. Then you mentioned some of the the dyno that you got started with that Kurt helped you with, and then you've added additional versions of that since then, and other types of equipment. Tell us about that. Tell us about the different kinds of gear that you guys are using nowadays, and then that'll kind of lead us into the digital fabrication stuff you're doing now.
Sure. So the testing equipment that we use, the basic premise of the shock dynos is it's a crank dyno. So it's a motor that sits inside of a machine, and it spins and runs an actuator in a sine wave. So as it spins, it's in a yoke, and it just runs a sine wave. So on the other end of that shock, so we drive one end of the shock with the motor, and the other end's hooked to a load cell. So the dyno's hooked to the computer. We collect all that data and turn it into a plot or a graph that we can actually see what the shock is doing and how it's performing at all the different velocities.
And I saw, if I understood this correctly, I was watching one of your videos, you actually have the ability to take like actual track data, like from an actual drive, and bring that into that system to simulate it?
So after we started this business, Kurt Rohrig had developed what they call their EMA dyno. EMA, it stands for electromagnetic actuator. And basically this dyno has no constraints. It's not hooked to a motor. It's driven by two magnets.
Mm.
And we can input any waveform, whether it's a sine wave or a triangle wave. We can run square waves, or we can import custom profiles that are taken from data acquisition on the race cars. We can take potentiometers that they hook to there, import that straight into the dyno, and run the shock just as it is seen on the race car.
That is so
And
cool.
just like 3D printing, the shock market grew in leaps and bounds through the 90s and the early 2000s with the testing equipment, and we were finding things that we didn't even know was happening with the shock. And right now it's all kind of leveled out. Like all the stuff that was unknown, we're starting to figure it out now. But the late 90s and early 2000s, it was every week you turned around, we were learning something new. We built, oh geez, this would have been about 10 years ago. We actually built a clear shock. So we built a shock absorber out of a clear. Jeremy, I'm at a loss for the material that it was, but it was huge. A normal shock absorber is about 46, 47 millimeters in diameter. This shock tube was probably 4 inches around. Wow. And we mounted it upside down in the dyno and took high-speed video of the shims and watching how the shims were opening and closing. And we learned that in some cases the shim starts to bounce and we get into shim flutter, and there was all kinds of stuff that we never knew that was going on that now became possible because of the equipment that my partner had developed.
Very nice. Very nice. So obviously, this is that it's not all about the equipment. It's also, of course, about the tremendous amount of expertise you have on your team. I saw in one of the videos you said you had something like 125 years of combined racing experience.
Yep.
That's pretty impressive.
So between myself and my dad and all the guys that work on the shocks, they all race. They've all grown up racing, and I've got some ex-crew chiefs, guys that used to crew chief in the NASCAR series and whatnot. And it just, every time we onboard one of these guys, it just adds to our database of what all the guys bring to the table.
Yeah, nice. So that kind of goes back to what I was saying in the intro. I mean, you have this obviously a very successful business that was built with great people, with great technology, great services, the right contacts. You had all the right pieces. You've got a business that is just going wonderfully. But then you hear about, I don't know, 3D printing or laser cutting. Tell us about how you learned about the digital fabrication side of things, and how did you start to bring that into the business, and how has that helped? Let's talk about how that's benefited you.
Sure. So, in fact, I looked before we did this segment. I bought my first 3D printer in 2014, and at the time I knew 3D printing. I knew that it existed, and I knew it was out there. But in my mind, that was something that was so far beyond the realm of my little business here in Mooresville, North Carolina. And one day I had a customer come in, and we got to talking about it, and he was telling me about MakerBot. Actually, he was like, yeah, MakerBot just came out with this new printer. It's a desktop and anybody can do it. And I'm like, yeah, okay, well, how much is it? And Jeremy, you'd probably know better than me. I think at the time it was like $3,000 or $3,200. And it's like, really? So at the time that he was telling me about this, we were in the process of making some part. I don't remember. It was a new widget for shocks, and I had to make two or three different prototypes. And those prototypes from the machine shop were coming back at like $800 or $900 a piece. And so I was sitting out here, and my dad was out in the shop, and we got to talking about this 3D printer, and I pulled it up online, and I'm like, these three prototypes that we just made, would have more than paid for this 3D printer. And again, I don't remember what it was, but the part that I needed, I simply needed to hold it, and I needed to put it in place and see that it was right and the lines were right and all the, basically if my drawing was correct.
Yeah.
And that's all I needed. So we bought one.
And what about, before we talk about the printer, when you were using this outside machine shop for prototyping, what was the turnaround time on getting a part done?
Oh, well, at that time, it probably would have been a week or 2 weeks to get a prototype, and you get it, and within 10 minutes, I knew whether or not
Exactly.
it was right, whether I had drawn it right, or if that part's going to work. I mean, you knew immediately, and it was almost a no-brainer. So, that was the only reason that we bought a 3D printer, was to shortcut this prototyping stuff, because what we were doing at the time was basically a lot of hand tools. Again, in our industry that was at the time growing leaps and bounds, there was nobody that made tools for the job that we needed to do. So we started making hand tools, and the prototyping was just like I've got one here that we prototyped a wrench. It's like I needed to hold it in my hand, and I needed to put it up to the shocks, and it's like, are all these things in the right? I just needed to hold it. So we got this printer, and we played around with it, and I spent a ridiculous amount of time just playing with the 3D printer and seeing what I could do and what I couldn't do. And with me having drawing background and CAD modeling, the sky was the limit. So I was printing widgets and brackets and holders for your phone, and somewhere in there, that first printer that we got, it was not good. We had a lot of issues with it, and that's actually where I called 3D Universe, because I needed a printer, and whoever, one of your guys up there, picked up the phone was awesome, answered all my questions, and I bought it, turned it, plugged it in, first print without any adjustments. It worked great, and we're getting these prints off of here, and it dawned on me, it's like, man, for what you have in a spool of filament, $40, it's like I can make a lot of parts out of this and sell it. And it's like,
but before we get into actual end use parts, because that's a whole other story, I want to talk a little bit more about the prototyping. So you said before $800-900 a part when you were outsourcing this, and it would take 1 to 2 weeks to get a part back. Now, the 3D printer, how much does it cost you to print a prototype of something like the wrench that you showed us, would you say?
a couple dollars.
And about how long? What's the turnaround time on printing one of those things?
Average print time that I've got here is like 6 to 8 hours for the size of parts that we normally print. Like, there's some stuff that only takes an hour or two.
Right. So I'm not going to ask to do this off the top of my head, but that's got to be that's got to be a huge savings in both time and cost. I mean, that's
immensely. Yeah. And above and beyond that, now that I've got my own prototyping capability, and it's like we can envision it, we can draw it and print it. Now it's opened up the creative side of our business. It's like we can think it and spit it out in the printer, and it's like, okay, well, let's take that and move this and do. Oh, it's just opened up so many doors.
There, yeah, it's the ease of iteration, the ability to just so quickly and affordably churn through ideas. You don't have to worry if you get it wrong the first time. To me, that's so powerful. I mean, because it's a lot cheaper, sure, but that week downtime, the 1 to 2 weeks, that's what gets me. You can't do anything until you get that part back, and then you realize immediately it's wrong. You just you kind of waste it.
Like, oh, I've got this radius wrong, or this hole needs to move 10 thousandths to the left, and it's so it was a complete game changer for us. It's on the manufacturing side of it.
Yeah, because there's kind of a momentum to these kind of prototyping and development initiatives, right? If you can keep it going, you're going to get a lot more done.
Absolutely. It's like that, the creative writer's flow. It's like once you start spitting these out, then more ideas follow it. And, again, as long as you have the capability to roughly hack it out in your CAD software, it's like it's right there, and good ideas lead to more good ideas.
Yeah, right. Okay, so now, so it's obviously a powerful tool for prototyping and helping you to iterate more quickly and easily. But then you were just kind of moving into having these ideas for possible actual finished products that you could print. So let's talk about that. And we don't have to limit this discussion to 3D printing either. I mean, we're all about digital fabrication. So I know you got some laser cutters there too that you're using as part of customizations and stuff. So let's talk about that. What are you doing with the actual products that you're selling to your customers now?
So, well, the products that we sell, Jeremy, started out no different than anybody that's ever bought a 3D printer. You start looking around the house or looking around the shop, and it's like, oh, I could build a gadget to hold this, or any kind of widget. And so I had started, at night. To back up, and it's not fair because I treat my CAD software like most people treat video games. It's like I that's my pastime. I go home and draw something up, and my dad brought home a birdhouse the other day for my wife to hang up, and I sat there and I looked at it, and it's like, oh, I can model that, and then I'm a strange individual, and that
Like little
has
birdhouse furniture, right?
yeah, exactly. I'm getting ready to refinish my deck. So, instead of doing math, I just modeled my deck out. And now I know my square footage. And
Love it.
yeah,
It does.
so
My mom wanted to build out a custom camper van, so I did the same thing. I modeled it up for her, and it's a lot of fun.
right, it's a way overkill, and I'm fully aware of my issues. Um, so I started building, holders here at the shop, and tools to help. And I had built, actually, where is it here? I'd actually built for our guys a piston tray. So in building shocks, I my guys like to lay out. We build shocks or race cars have 4 shocks. So when my guys build shocks, it's like I built this little tool to lay out all 4 shock builds with the piston and whatnot, and I set them on everybody's bench. And one day I was just sitting there. It's like, I have no idea on earth why we don't have those on our website.
Absolutely.
And now we put them on, and I've got one printer. I actually turned it off for this show, but I've got one printer that does nothing but run these piston trays.
And that's a great example of you got to think about which of these, different parts are really good candidates for 3D printing. I'm just looking at that one. You got a nice flat base, no need for
Yep.
supports. You got a simple dual extrusion print for the 2 colors. It's perfect.
Yeah, absolutely. And there's nothing hard about it. I mean, it's not hard to draw. It's 4 extrusions, and
Yep.
and when you start messing with 3D printing, you've got to learn, the weak points, and where 3D printing is strong and where it's weak, and it's all easily fixed. You just have to understand what you're working with.
Exactly.
So we started there, and then and it grew from there, Jeremy. We anything that has a handle. So like in our dynos, we've got I don't have one, but we've got handles with a pin in it where we clamp the shocks into the dyno.
Okay.
And again, I used to have all these handles machined, and then we'd stick the pins in the freezer, and we'd heat the handles and drive the pins in there, and make it. And it just dawned on me, it's like perfect anything with a handle is a perfect candidate for 3D printing. And again, there's nothing complex about it. It just works, and it's cheap. And if you stay ahead of it, you can keep up with the volume. Obviously when a certain product takes off, and we've had a few where instead of selling, 10 or 20 a week, now you're up to 50 or 100. And it's like, you start weighing whether or not I should buy more 3D printers to keep up with it, or let's get this sent to the machine shop and let them handle it. So it definitely has its place for end use products, but as long as the volumes, in check, it's a great tool.
Yeah,
Great tool.
'cause it's allowing you to kind of ramp up the production on these new products as demand ramps up. So you can start very small, you can build up, and then at a certain point, you can always make the decision to switch over to more traditional manufacturing methods when it gets outside
Right.
of the can do.
Yep.
That's pretty cool.
So after that went, it was probably 3 or 4 years ago. So all the parts that we have manufactured, we'd have manufactured, and they'd come back in, and we'd send the parts out. Primarily, everything we do here is aluminum.
Okay.
So we'd get the parts in and then send them back out for anodize, and the parts would come back, and then we'd send them out again and get lasered with our logo and part number or whatever markings that it needed to have. And just like 3D printing, I was sitting there looking at it, at how much money we'd sending these parts out to get lasered. And I looked at a couple lasers and honestly likened it very much to 3D printing. It's not complicated. It's a very simple machine that works in X, Y, and Z. And so we bought one. Well, now I've got to the point where a lot of the parts that we make, like these are spring rubbers that when we get in, we laser with the part number and we put our logo on it or whatnot. But our laser has a rotary. So I took off all the hardware that the laser company sent with their rotary and installed our own drive. And now we make, I've got 50 or 80 of these jigs like this to do all round parts, and it sits there and spins. And so
the white part there is just a jig that you're.
Yep, that's just the jig, because so much of the stuff we do is different diameters.
Yeah.
So we've got a whole counter full of parts like that back there, and on top of, if it's a part that's hard to hold, we'll 3D print a fixture to sit it, so that the laser knows where it is and X and Y, and it's that our printers are going pretty much nonstop.
That's fantastic. So you've certainly gotten your money's worth out of them.
Oh, for sure. We went from the first, we bought an Ultimaker 2 and turned it into a 2 Plus, and then we bought another 2 Plus. And then I got another one, and then took the one that I had here at the shop, the oldest one, and took it home. And then now we've got the, what do I have, Jeremy? The 5S.
Yep. Looks like the S5 Pro bundle behind you there.
S5. So we got the S5. So I've got 4 printers, and like I said, they are running more than they're not. It's a great tool. I don't know how anybody that has CAD experience doesn't have one of these.
Yeah, just bringing those.
Even if you don't have CAD experience, with what's out on the market now with Thingiverse and all the models are out there, and you can just make them and scale them, and it's
or even learning CAD. I mean, it's not something you need to be scared of these days with Tinkercad, and
absolutely not.
Anyone can learn it.
And it's not, you just have to think in XYZ and get in there and start messing with it. And there's a lot of the CAD programs out there that are very affordable. It's here in the racing industry, most of us use SolidWorks or and those programs get to be real expensive, but it's not necessary at all.
No, and I mentioned Tinkercad, which is a free one that's good for some people getting started. I use Autodesk Fusion 360, which is a very powerful tool, kind of
and very affordable.
Not only affordable, it's free for personal use, which I use it for my work with Enable for the volunteer community that I'm with. So yeah, I mean, anybody using it for non-commercial purposes can get a free copy. So it's a great way for people to get started and learn.
Yep, for sure.
Then now, we had a little bit of a discussion earlier on about a new product that you're kind of working on. Is it okay to talk a little bit about these bump stops that you've been playing around with?
Sure.
So tell us what is a bump stop? What's it used for?
So in race cars, obviously, in a race car or your street car, springs hold the car up. Well, with the way that the setups and the trend of racing is going today, our whole object in racing is to try to get the car as low as we can to the ground and hold that platform. So we want the dynamic ride height of the race car to be in as little a window as we can, so that we can control all the variables with camber gain and caster and the wedge in the car and whatnot. So what we came up with many years ago is basically put very lightweight springs in the car and let the car come down to the racetrack, and then on the shocks we catch the car with these bump stops. So we basically, as the shock absorber compresses, we put something like this on the shock absorber, and as it comes down and sits on it, that's what holds the car off the racetrack. And as simple as a part as this seems, there is so much in how we build up the force, and how we get to the forces we need to keep that car off the track. You know, the most common right now is we use like a polyurethane stop in different shapes, different heights, different sizes, multiple stops, and it's all in creating different force curves to get to the target that we're shooting for. So not that long ago, a customer of mine called in, and he wanted us to make some solid polyurethane stops for him. And he sent in some bump stops that somebody had 3D printed. And again, we use 3D printing every day, but like we were talking earlier, I'm not in the forums, and I'm not really aware of what was available and whatnot. So I look at this 3D printed bump stop and I'm like, wow, I never even occurred to me that we could do something like that with 3D printers. So I called my buddy at 3D Universe and I was like, hey, if I'm going to do this, what do we need? And you guys hooked me up with a whole bunch of different materials to play with. And for the last, 2 weeks now, 3 weeks, we've been playing with different shapes, different sizes, different infills, different infill patterns, density. We've been playing with the number of shells and the overlap into, how much the walls are connected to the infill. And we're learning a bunch. We're learning again. It's exciting again, because it's like we never thought it possible. So right now we're in the middle of working out, of testing, looking at the durability, because obviously, we're printing these layer by layer by layer, and it's a concern that we have that those layers, I want to make sure that they don't shear and that these parts retain their height, that we don't distort them with all the load that we're putting on it. And it's really fun right now.
It's fascinating to me because I have never run into somebody that's in the position that you're in, where you have the 3D printing as a tool there, and so you can prototype this product, but you also have all of that testing equipment. So you can modify a parameter, like you were saying. You can change the infill pattern or the amount, and then you can stick it into your dynos and test it and see exactly what that did to it, and that's powerful.
Exactly. And it really is cool.
I mean, I guess we don't know yet if this is going to work, if it's going to be a successful product, but you're sure learning a lot as you go.
Learning a bunch. And I think one of the biggest contenders that we have in working in the bump stop is, so that where the shock absorbers are mounted in race cars are real close to the brake rotors,
Okay.
which get really hot. And that's been something that, as far as 3D printing is concerned, I've struggled with over the last couple of years, of learning the limits of how hot can we run certain parts and certain materials before they start deforming or giving up and whatnot. And this is going to be another one. It may be something that we can only do on open wheel cars, where the brake temperature doesn't get so hot and it's out in the air, and it can
maybe not. So you and I will definitely have a follow-up conversation on this, because you're following the same path that I think so many people do. You first become aware of 3D printing, and you get a 3D print and you're amazed at what you can do with it. And at first you're probably using mostly the basic materials like everyone else, PLA, maybe some ABS.
PLA and ABS.
And maybe some tough PLA nowadays, but that's it for most people. And then sometime later, you start to become aware of this world of materials that is constantly expanding, especially with the ultimakers that you have, because it's an open platform. You can use any materials on the market. And yeah, there are some really good. There's some flexible, high temp materials that we'll talk about that might be worth exploring. There are so many different, options that. And what I love about this is, like going back to what you were saying about the investment you made in that printer, which was obviously nothing compared to what it's doing for you. But then on
Right.
top of that, you continue to be able to get more and more and more value out of this tool as these new materials come into the market. You don't have to change a thing on your printer. Just,
Right.
new materials keep coming out with all these fantastic properties. And so you just keep being able to do more and more and more with this machine. It's
Yep.
wonderful.
And you're exactly right. And that the whole key, and God, that's what I love so much right now about 3D printing is that it's it's going way faster than I can keep up with it.
Yeah.
So just keeping your finger on top of what's available, and it's exciting. It really is. Even for a very specialized company like what we've got, it's like there's stuff on the horizon that is a total game changer. It really is.
That's awesome. And I want to talk about that before we get into that. And I should have mentioned this at the beginning, but I'll just say it now. For those watching us live on Facebook, feel free to go ahead and post comments there right under the live video. We're going to see those here. If you want to ask questions, if you want to share any kind of comments or observations, please feel free to do that in the comments there, and we'll bring you into the discussion here. So start typing as we talk. So we got a little more to go over here, but I want to get input from the audience as well. So use the
Sure.
comments for that. So yeah, going forward, let's talk about that a little bit. What do you? There's so much going on, like you said, with digital fabrication, new tools, new capabilities. What are some of the things you're thinking about going forward? Anything you got your eye on that you're not doing right now, or that you want to do more of, or anything like that?
Um, Honestly, Jeremy, what I've got, what I'm sitting here anxiously waiting on is metal 3D printing
Oh
to
yes,
come down to a cost where RE suspension can implement that. So, obviously, with what we do in shock absorbers and the parts within the shock, if we could ever get to the ability where I could 3D print pistons
hmm.
and start changing the flow characteristics, and oh man, that's like my dream. And I know that it's out there and it's currently being used. It's just not something that we can play with right
Well,
now. You know what I'm saying?
just from that point of view, just to play with it and maybe do some prototyping. We do have this new material from BASF called Ultrafuse 316L, and you can print it on your Ultimaker right there behind you, and because it's mixed in with binders, and so you can print it
Right.
on your Ultimaker. You put it in a box and you ship it off to DSH Technologies. They do the debinding and the sintering, and they ship you back a solid steel part. So you can
Really?
do this, yeah, if you want to give it a shot. Now I don't know how that's going to compare to something manufactured in other ways, but you can do that now. That's one of those fantastic new materials that just came onto the market recently, and
Yep. And that's like what we were talking about. I was not aware,
yeah,
and
yeah,
it's exciting.
it is.
So, besides that, no, we're looking at in the very near future at adding another CO2 laser, and we're currently farming out different quotes from fiber lasers.
Okay,
So there's a handful of things that we do here that where we're trying to mark stainless steel or titanium and CO2 lasers, unless you want to use Surmark or some kind of marking material on top
right,
of it, CO2 lasers won't cut it. So
yeah,
we're looking at expanding there, and the ultimate goal, the end goal, what we really want is to bring all our machining in house. I would really like to do that. It's just right now, Jeremy, we're so busy and business is so good and
right.
racing is taking off. Despise the pandemic and COVID and all the things going on in our country, racing is out of control right now.
Yeah,
So,
we'll need that.
we're just doing all we can to make sure orders get filled.
Yeah, I bet. That's awesome. And you're doing it right. You know where you're headed, but you're doing it one step at a time and just adding these tools and increasing your capabilities as you go. And I'm sure you'll get there where you can bring all this in house. You're just doing it kind of a piece at a time. That's really smart.
Absolutely. Absolutely.
Yeah. So you talked a little bit about some lasers you got your eyes on and increasing your capabilities there. On the 3D printing side, is it just kind of more of the same, or are you looking to kind of increase capacity a little bit and keep doing more of what you're doing?
I am, before the year's over, we'll end up adding another S5.
Hmm.
Because again, when we went from the Ultimaker 2s or the 2 pluses to the S5, once again, that opened up a whole nother world for us. With being able to print with dissolvable support material, dual extruders, it opened up just that many more possibilities, that many more combinations. Here recently, we're working with a company that's developing a brake system for the karting industry. So we printed vented rotors, again with a dissolvable support material, and air scoops. So I wish I'd have had a sample of that, which
All right,
was really awesome.
but for the people, we might have some people watching who might not be aware of this. What we're talking about, it's usually PVA. That's the material that you're probably working with, but it's a water soluble support material that you can print because some of the more complex geometry you need to print with supports, kind of a scaffolding to hold it up as you're printing it layer by layer. And these soluble supports, when you're done printing, you just drop it in water and the supports just dissolve away, leaving you with this beautiful clean part, which gives you pretty much complete geometric freedom then for 3D
It
printing.
does 100%, and again, with the default settings from Kira and the Ultimaker, I did very little tweaking
Yeah.
with what we needed to get a really nice, clean, finished part. And again, that was just for prototyping purposes, but it's like the prints that came out were just great, and that was one of the first things we did with this printer when we got it. And since then, now that I know that we can, print overhangs without supports, and the cleanup after, if you do something like that, the cleanup to come and break the supports away and touch it up can be very labor intensive. So now it's like, you print these things and it gets all done. You pop it off the plate and throw it in a thing of warm water and walk away. Come back, 4 or 5 hours later, and it's your part's ready to go.
Yeah, I love it. That's great. Well, that's pretty cool stuff. So, how would you say overall, how has the digital fabrication, the 3D printing, the laser cutters, how has all this helped your business? What have been the advantages of that?
Again, it circles back to what we were talking about before. It opens. It really helps open our creative mind as to what can be done. And I don't, there's been a dozen or more times where we've been out in the shop and one of my guys will have this great idea. It's like, hey, if we do this, like, we could turn this into a part and sell it as this combination. That's like, hang on, give me a minute, and come back here and draw it. And before the end of the day, it's like, you mean something like this, and we'll put it on the shock, or we've got a mock race car in the front of the shop here. Go out to the race car and hold it in there. We work real closely with a handful of chassis builders around here, and we're starting to use 3D printing for mounting dashes, mounting gauges in the car. As we speak, I think for years now, we've been 3D printing fender washers to hold valences on, helmet hooks, anything that, if it requires a lot of strength or it needs to be tough, we mill it out of aluminum or steel or something like that. But for where 3D printing fits, it's become the default go-to for those who have one.
And so, are you kind of developing for yourself a sort of, I guess, what we could call almost like a digital warehouse where you have kind of these different parts that you've designed and you can just kind of, oh, I need another one of these wrenches. I'm going to go grab that model and print one off, and that kind of thing.
Yeah. Well, honestly, again, if you go back, if you go back to the Ultimaker 2 pluses, I've got this one memory card that has, this is the one you don't erase, you don't do anything. These are put it in the machine and hit print and go. And yeah, we've got a lot of them. Again, going back to, helping the guys in the shop with organization or just little widgets to make your everyday life easier. It's we all the time. The printers are going nonstop.
And that's part of what I find so cool about this is I hear this every time when I talk to people like you is that you buy the printer because you see a certain opportunity to to benefit your business, but then you start discovering all these other things that you maybe didn't expect. Oh, I can do this and I can make one of these, and you find all these additional ways to put it to use. I hear that constantly.
Oh, when I so when we got the third printer, I took my oldest one here at the shop and I took it home. And we I have printed every drawer divider for the kitchen drawers in our house. I have printed hooks, and I've printed. There's so many plastic parts at my house. My poor wife, I know she rolls her eyes every time I bring this in. The other day, I made a holder to hold the coffee filters. We have those triangle coffee filters at
Yeah,
home. So I printed a holder to set those there, and she's just like, "Oh Lord." But you can't help it, right? I mean, the whole process becomes addicting.
I hear you. It's the same in my household. Same thing.
Yep.
It's a lot of fun.
Yep. So it's yeah, it's I don't know where 3D printing is going, but I know where it's come for us, and it's I can only see the future where everybody has one of these, whether you've got modeling capabilities or not.
Mm.
It's just they're great.
They are. Well, I really loved hearing what it's done for you. You've got a great thing going there. I wish you nothing but the best of success, of course, but it's been really wonderful hearing what you've been able to do and continue to do with these digital fabrication technologies. I just love being able to share this with our customers, and these stories are really, really, I think, are empowering, help to inspire people that, I
Very much.
so many people that I've talked to that have had this, something of a passion that they've wanted to pursue, and I just love how digital fabrication can be a part of that, of helping to open up these doors and let you explore these areas that you might not have been able to otherwise. So I appreciate you sharing your story with us. Look forward to hearing more about how things go. I'll certainly be keeping an eye on, and let's have that follow-up conversation about those materials because I got some good ideas for you on the flip side.
Absolutely. Absolutely. And like I said, Jeremy, thanks for having me, and I look forward to all the things we can do.
Absolutely. For our audience, thanks so much for watching. We got a lot more great 3D Universe Untethered content coming up for you, so check it out as always on our blog, 3duniverse.org. You'll see a little graphic in the upper left corner with a big microphone on it for 3D Universe Untethered. That'll take you to the full listing of what we have going on. So thanks everyone for joining, and thanks again, Jason. See you all next
Thanks.
time.
Thanks for having me.